But yeah, I'm very excited to be talking to you guys about the buzzword of 2022, zero trust. Who knows what it is? I actually asked my kids to do something for me, and when they came back, I said, "You have zero trust. You did it right." And they looked to me and they said, "That's not even a word." I've been evaluating my career choices since. Zero trust is the new buzzword, and I wanted to talk about, the architecture as specified by NIST, specifically document 800-207, and its applicability on the Wi-Fi side. I'm not going to give you the PBS special, but I'm just going to give you like high-level, key points. Why do you need a framework like Zero Trust? As you're aware, most enterprises are operating in a hybrid environment. Majority of the applications have migrated to the cloud. Business critical applications are now in the cloud. You don't need to be on a corporate VPN to access Salesforce.com. You could be anywhere. And more importantly, you could be on any device and access Salesforce, or go to, access login.microsoft.com, or go to your Okta account. So you could be anywhere. And so that's where the document begins with the statement that there's no implicit trust that is granted based on the physical or network location. So it doesn't matter whether you're on corporate SSID or guest SSID, the location of your device is irrelevant. Which means the network is no longer the perimeter. The focus is now shifted to identity and device, and how we need to bind these things together. The document and the framework actually talks about specifically two things: authentication and authorization, and ways to modernize these two key elements. They're very specific about saying that you need to eliminate passwords and move towards phishing-resistant MFA solutions. We are all here, and most of us are still leveraging username password-based solutions with a band-aid of a push-based notification that comes on your phone. Well, these have proven to be phishable, and so we need to be moving towards phishing-resistant MFA solutions. So what do these phishing-resistant MFA solutions which eliminate passwords look like? Well, when you eliminate the passwords, you need to be replacing these passwords with asymmetric public-private key pair-based mechanisms. For those of you who are aware, certificate-based authentication mechanisms have been around for many, many years now. There is still a challenge with cert-based authentication in the way it's traditionally deployed, because there is a central root CA that has a centralized private key, and that's still vulnerable. If that gets compromised, you still have an issue. So what we are talking about is to be able to leverage decentralized ways of generating this public-private key pair, and we need to generate that right on the device itself. Now, if you're generating public-private key pairs right on the device, where do you store the private key? And this is where majority of the devices that are in the market today, and actually have been available for the past 6 years, come with what is called as a trusted execution environment, a TEE, or other words for it is something like a secure enclave. If you look at your Windows machines, your Mac machines, there is something called as a TPM on Windows. There's something called as a T2 chip, and this is where you store the private key when you're generating that on the machine. So you're basically generating a local certificate authority, decentralize it, rather than having a centralized certificate authority. And then the most important thing that the Zero Trust architecture focuses on is device security posture. Now, for those of you who've been leveraging any sort of a NAC solution in the past many years, and quite a lot of enterprises have deployed like an Aruba ClearPass or a Cisco ICE or any other NAC solution that's available in the market, they do limited device posturing. But if you go by the Zero Trust framework, you need to kind of delve deep into the device and capture like operating system level risk signals and write policies based on that. And you have to go further away from just doing the device security posture at the time of authentication. You have to do the posturing on a continuous basis, which means that you have to check the posture almost every 10 minutes because, I can authenticate and authorize at the time of authentication, but what if something changes? What if something comes into my network, into my device and turns off the firewall? I need to be able to detect that. So the key point to take away from this is that to achieve true zero trust, the identity layer needs to feed signals into the network layer and use the network layer for enforcement. And this is what I am going to be talking about in terms of how this authentication model looks for Wi-Fi. So in this particular example, you can see that the good news is that majority of the Wi-Fi vendors that are in the room today, like Mist, Aruba, Arista, they all support this delegated authentication model, where they are able to delegate the authentication using standard protocols like SAML or OIDC to a third-party identity provider, like Beyond Identity. Now, Beyond Identity, for instance, is responsible for achieving these principles that has been laid out by the Zero Trust framework. So the device and the user connect to the Wi-Fi network. They do, .1x based mechanisms to achieve, over-the-air encryption, or you can do OWE. So you've achieved that over-the-air encryption. Now comes the main part. Is this device and user tied together? Are they allowed to access my network? And that's where the delegated authentication model takes place. So you've done layer 2 based authentication. You've assigned your VLANs. Now you go to layer 3 based authentication, which most of you are aware of today with the captive portal model. Here, the layer 3 based authentication uses a SAML or an OIDC redirect. And the job of the identity provider is to generate that public-private key pair, make sure that the identity and device are bound together, check for the risk signals at the time of authentication, look at the enterprise ecosystem, make sure that the enterprise, you have, like for instance, we are leveraging some sort of an EDR. You have a CrowdStrike client running. You actually check the CrowdStrike cloud to ensure that, yes, this device is running a CrowdStrike agent, and so on and so forth. So that's just one example. Once that is done, that's the only time you assert the identity and ensure, inform the Wi-Fi cloud that, yes, this device is allowed to access the resources. And then comes the most important part. You have to do the authorization. I say continuous authentication, but you're basically authorizing the device every 10 minutes. Now comes the true zero trust part. What happens if the posture changes? This is where, if something changes on the device, I need to be able to signal to the Wi-Fi layer to take action. This is where the enforcement would occur. So I have 2 minutes, and I wanted to show you a demo with this. I know I have to run quickly, but so this is, Keith, if you don't mind, I might go like 30 seconds over. So all of this into action is right here. So what you're going to see is a different way of logging into the Wi-Fi network. So I have a device, but let me set this up. This is a Windows machine that is managed by the enterprise. This could be an unmanaged device, this could be a managed device, it doesn't matter. In this particular case, the Windows device, that is a managed device that has an authenticator that is running, that has generated a local certificate authority right on the device, meaning there's a public-private key pair, public key is sitting in the identity provider's cloud, private key is stored on the TPM of this device. That's the one that's replaced your passwords. Now, I'm going to go ahead and connect to an SSID, which does both layer 2 and layer 3. By the way, both Mist, and Arista, as well as if you are leveraging Aruba ClearPass, they support this model. Do the L2 first, and then go to an L3-based authentication. So I'm going to do .1x first using EPTLS, because again, that's passwordless. And now I've initiated a layer 3-based flow where I have instantiated a browser to do a SAML-based flow. Now, if you look at the SAML standards, that's what they're telling you. You need to use browsers to do that. Nowhere did the user have to put in a username password. The identity provider's job is to ensure the binding, meaning is this identity tied to this private key, which is in that TPM. So it's signing that signature, the identity is verified, and the user is logged on to Wi-Fi. Now, from this point onwards, when I come back to the office or connect to Wi-Fi, I don't need to go through this flow again because the app or the authenticator is doing continuous authentication. So what you need to do is continuously evaluate the risk posture. So I'm going to write a policy in the identity provider cloud, and it's a very simple policy. All I'm checking for is is the firewall turned on or off? And if the firewall is off, for any reason, I'm going to disconnect that user from Wi-Fi. So I'm going to write a policy which says, if this is a Windows machine, and your firewall, and you can see there is signals, there are hundreds of signals that you can capture from the device, then I want to be able to disconnect this user from Mist. And they support those APIs. So there's a API from the identity providers cloud to the Mist cloud. And then I apply the policy. Now I'm going to change the posture on the device. And I've turned the firewall off. Now what's going to happen is you're going to see that continuous authentication is going to take place. And at this point, within that interval, maybe that 10-minute interval, you can see that the policy is now, the posture is now changed. A deny policy comes into play, and a closed loop integration will occur. So this is the true zero trust access that you're seeing here. The identity layer detecting that the authorization has changed, and now I'm enforcing it on the network. So here is where the device disconnection would occur. An API call goes to Mist for this particular user, for this particular device, because my user can have 10 different devices. I want to be very precise that this device's posture has now changed. I'm going to reauthorize this particular user. You're going to see the reauthorization occur. Now comes the closed loop integration. When the device tries to log back in, it is not allowed access. And this, gentlemen, this is how we achieve true zero trust in the Wi-Fi world. Thank you very much.